So, Hedgehog is what I came here to present today. Thank you guys for coming to this presentation to hear about it. And let's get started. What is Hedgehog? Well, as the gentleman who introduced me just mentioned, Hedgehog is a protocol for two-party payment channels. And what's kind of cool is that they're very similar to Lightning channels. Like, in fact, if you look at the Lightning specification, you just remove a few things, you get Hedgehog. But there are a few comparative benefits to it that I want to go over in this little presentation. So, what are those benefits? Well, this slide actually used to be two slides. I had one that described the benefits in bullet points, and then, anyway, I merged them. But the kind of demonstrates the benefits is that Hedgehog's only got two, what's the phrase, like phases per state update, whereas Lightning has four. So in the Lightning Network, if you want to do a state update, which means you want to send someone money or you want to receive money, what happens is the sender, let's suppose they start out as Lightning channels usually do, the sender starts out with 100% of the money, and they want to send some amount of money to their counterparty. So let's say they have 100,000 sats in their channel and they want to pay their counterparty 50,000 sats. The first step is to create a proposal where they say, I would like to change the state to this, where I have 50%, you have 50%. Then they have to wait, and when the other person gets online, the other person has to be online. What?
I lost you. You went back on mute.
I'm on. How did that happen? I didn't touch anything.
I have no idea.
Yeah, that was weird. Let me make sure the recording is still going. Yeah, it seems to be. Okay, so yeah, in Lightning, when you want to make a state update, you propose a state update, and then you will wait. You wait while your counterparty decides whether they want to accept that state update or not. And once they do, then they do something called ACK and revoke, where they say, all right, I acknowledge the new state, in this case the 50-50 split, and I revoke the previous state where Alice had 100% of the money. So in Hedgehog, it's a much simpler procedure where if Alice wants to send Bob money, or vice versa, the sender is the one who revokes the old state and says, here's a proof that I can't spend using this old state anymore. And what did I do again?
Yeah, we're not getting your screen share for some reason.
Well, I'm back. I don't know what's wrong with it. I'm not touching anything. Maybe it's my connection.
I haven't had that issue before. I don't know if it's because of the recording.
Yeah.
It's kind of weird. I would think so, though.
I suspect it is my connection. It dropped to 2 bars. So I'm going closer to the Wi-Fi, and maybe that will fix it.
We don't see your screen share anymore.
Yeah, that turned off too, but I'm just turning it back on. So
there we go.
I'm closer to the Wi-Fi now, and maybe it won't do that anymore. I assume it's doing it because of connection issues.
Could very well be, no problem.
So in Hedgehog, Alice is the one who revokes the old state, and she says, I'm gonna create this new state where there's this 50-50 split, and I also send you a proof that I've revoked state 1, so that I can't go back to the state where I had 100% of the money anymore. And the main difference between Hedgehog and Lightning is that in Lightning, the sender waits till the recipient revokes old state, and their wallet shows a pending payment until that happens. This is sometimes called stuck payments in Lightning. Whereas in Hedgehog, the sender revokes old state unilaterally. So the difference is who revokes. The sender revokes in Hedgehog, whereas the recipient revokes in Lightning. And because the sender does this automatically, their wallet immediately shows a settled payment. So you never get stuck payments with Hedgehog. There's a lot of other cool properties, but I do want to talk a little bit about how Hedgehog works. And just like Lightning,
you got muted again.
It's almost like it's a consistent period of time between every time it mutes. Like there's some sort of timeout, like something's trying to go to sleep, or I don't know.
Let me see if am I still screen sharing? Yeah.
Or when people leave. That's a good point.
Yeah, maybe
fellow Jetser left last time, and it happened that's when it muted and the screen went away.
Yep, maybe when people are coming and going.
Perhaps, I don't know if it would.
Got you back, at least the screen.
Yeah, I'm just gonna see if I can
Yeah, he's still just on mute. Otherwise, but
yeah.
Okay, I'm just seeing if there's anything in my configuration settings to change any of this. So I just made it so that performance goes down towards best performance rather than highest quality. So that might make a difference. And I don't know if there's anything else I can do. I can't. I don't like if it has to do with people leaving. I can't really control that.
No.
Yeah.
No.
Okay, so continuing the screen share. So I want to talk a little bit more about how it works. So how it works? Well, when you create a Hedgehog multisig, it's just like a Lightning multisig in that there's a 2 of 2. There's 2 key holders, and they both have to agree in order to spend any money. And when you want to spend money from this multisig, let's say there's 100,000 sats in it, the sender has to create something called TX0 and TX1. And TX0 takes all the money and it puts it in something called a revocable multisig. I try to illustrate what that looks like down here, and this is not exactly Bitcoin script, but it's sort of a way of representing it in a possibly more human readable way. But there's 2 spending paths in this on either side of the OR, and you can use either one to spend the money in a revocable multisig Bitcoin address. So the first spending path is multisig Alice and Bob, but they can only spend it after 2 weeks. Like there's a 2-week time lock. Once money goes into this revocable multisig, Alice and Bob cannot spend it for 2 weeks if they're using that path. The other path is called a revocation path, and if Alice reveals a certain secret, then Bob is able to spend the money as long as he knows that secret. He just has to prove that she revealed it by putting it on the blockchain, and then he can spend the money. And this is also a technique that Lightning uses when it does state updates. TX1 then, after the money goes into this revocable multisig, you wait 2 weeks, and Alice and Bob if Alice is sending money to Bob, she also signs a transaction TX1 that, using this path over here, the 2-week one, that distributes 100% of the money to Alice and 0% to Bob, or whatever the new state update is. So it starts out with 100% going to Alice. If she wants, so this is a kind of visual of what that looks like. The money starts out, let's say there's 10,000 sats in a 2 of 2 multisig. That's represented by this box over up here. And TX0 says after 2,000...
Can anybody else see the video?
Yeah, no, I'm afraid we're not able to see it.
This is really annoying. When did it...
Yeah.
So how long have I not been...
Since you started back up, I wasn't able to see the video.
Yeah.
I'm following what you were saying, but I didn't have a graphic.
This is really...
You see it there, and then for some reason, as soon as
You think
something happens, it flips back to just you speaking.
So can you still see it? Like
I see it now.
as soon as it goes away, let me know so that I can go and fix it. Yeah. So yeah, I was just describing this slide where all the money starts out in the multisig, then you put it in the revocable script, which is the one down here, and I tried to describe what this is, but it allows Alice to revoke this Bitcoin address and say, I can no longer receive money into this Bitcoin address. And then from that Bitcoin address, before she revokes it, she takes all the money to herself. She creates a transaction sending all the money to herself, and she co-signs it. In an animated form, it looks like this. The money starts out in this multisig, 10,000 sats. It moves into the address that Alice has the ability to revoke. She has the ability to make it so she can no longer receive money in that address safely. And from that address, then after 2 weeks, the money gets distributed. 10,000 sats goes to Alice, and nothing goes to Bob in state 1, because Alice is the one funding this channel. It's important to point out that Transaction 0 and Transaction 1 have not been broadcasted yet. Alice just has them. She has them co-signed by herself and Bob, so she can unilaterally withdraw. But the sats have not actually moved. They're still in that original 2 of 2 multisig. They are up here on the top right. But she has these 2 transactions, TX0 and TX1, which allow her after 2 weeks to withdraw the money. So no one's broadcasted them, but they are signed, and unless Alice co-signs them and then broadcasts them, they don't do anything. But as long as she just keeps them off chain and in her wallet, but not broadcasted, the channel is open. So let's see how to move to state 2. Let's suppose the sats are still in, well, not let's suppose, in fact, the sats are still in the original 2 of 2 multisig. They haven't moved. So if Alice wants to give money to Bob, she just creates a new transaction 0. She overwrites the previous one, putting the money into a new revocable multisig, and this one's slightly different. Instead of Alice being able to revoke, by revealing Alice's secret. Now Bob can revoke by revealing Bob's secret. So she's like transferring it over to Bob's turn. And the new one also has this other path over here where the multisig can spend. And so Alice signs a transaction using this, 2-week waiting path that gives 50% to Alice and 50% to Bob, because that's the new state. So in animated form, the money's still in this 2 of 2 multisig, but Alice signs a transaction that, if it gets co-signed by Bob, would move the funds into this address that Bob can revoke, and then from there, it creates, after 2 weeks, the 50-50 split between them. So now there's like a race condition, right? Alice still has state 1, Bob has state 2, either one can like co-sign and broadcast this, and so we have to have some way for Alice to revoke state 1. Well, that's easy to do, because back here, all she has to do is reveal this secret, and then she can no longer safely put money into that address, because this path does not have a time lock. If she puts money into that address after revealing this secret, Bob will be able to just take it. So that effectively cancels this whole thing, state 1, where she was going to get 10,000, and the only thing left is state 2, where Alice gets 5,000 and Bob gets 5,000. So she's effectively sent him 5,000 sats without actually doing anything on chain. She just sent him data that revokes state 1 and creates state 2 if he cosigns. So once again, she just signs those transactions, sends him the revocation key for state 1, and then when Bob gets online, he can co-sign that new state, or he can be like, I don't like this, and just not do it. But that's the neat thing. Alice and Bob didn't have to be online simultaneously. Bob didn't have to do anything. Alice did everything on her own, which is unlike Lightning. She doesn't have to wait for Bob to do anything, so she can just send him the data, and her wallet can immediately show, you've sent Bob 5,000 sats, without waiting for anything. So if you want to move to state 3, let's suppose Bob wants to send money back to Alice. Well, the sats are still in the original 2 of 2 multisig. Neither one's broadcast TX0 or TX1. So Bob just overwrites his own TX0, goes back into the one where Alice can, revoke this new state, and then he's going to distribute the money so that 75% goes to Alice and 25% goes to Bob. So he's paying her now. In animated form, the money's still in the original multisig. TX0 puts it in this one that Alice can revoke, and TX1 distributes it 75-25. And Bob just creates these transactions, TX0 and TX1, sends them to Alice, and also sends her the revocation key for state 2, so that she knows, all right, I can't broadcast state 1, Bob can't broadcast state 2, therefore we're only left with state 3, where I have 75% and Bob has 25%. Now, if you'll notice, we're in a loop. Like, Alice and Bob just keep doing the same thing over and over again, and they can keep doing that forever if they want to. As long as they maintain those transactions in their wallets, whatever the latest state is, they can just keep doing this forever, and at any time, either party can force close and go into whatever the current state is. So that's pretty cool. It's just like Lightning, except only the sender has to revoke the old state. And then there was the question, what about routing? Because the Lightning Network has similar properties to this, except it also can do like multi-hop stuff. And I haven't implemented routing in my implementation here, but I plan to base it on this specification by Matt Corallo, where he talks about how to do asynchronous payments on Lightning. And asynchronous payments on Lightning, if they existed, would be very similar to what I'm describing here, where you could send someone money while they're offline and just send them some text that they copy paste into their wallet when they get online, and that reveals they have that money. Matt Corallo wrote a specification for how to do that on Lightning with routing involved, and I like his spec, but I changed it a little bit. So in mine, let's suppose that Alice and Bob have a channel together, and Alice wants to send money to Carol. What she does is she creates an HTLC in a new state update. An HTLC is a type of Bitcoin address. She deposits money into it. This is all done off-chain. And this HTLC, she sends its private key and its pre-image to Carol. And then when Carol gets on, she completes the payment. And I have a little illustration of what this looks like. So we were in state 3, where Alice had 75%, Bob had 25%. So I'm pretending that Alice wants to send Carol 1,500 sats. So Alice does the regular procedure of TX0 and TX1, but her TX1 looks like this now. It takes 1,500 sats away from Alice and puts it in an HTLC, and Bob's money remains unchanged. Nothing's happened to him. So Bob can be offline, but Alice just sends this data over to him, and the next time he gets online and checks his wallet, he will see, okay, there's an HTLC worth 1,500 sats, and I have one of the pub keys to that HTLC, but I can't spend the money unless I learn the pre-image. And who has the pre-image? Carol has the pre-image. Carol also has the other private key in this HTLC. So the HTLC looks like this. Pub key X, which is Carol's pub key, can spend the money after 1 day, or Bob can spend the money if he learns a pre-image, with the pre-image that Carol has. So then Carol uses that pre-image to create a Lightning invoice. Lightning and Hedgehog use the same hash lock scheme. So she can create a Lightning invoice locked to the same pre-image, and if Bob pays it, that's how he gets the pre-image. And once he has it, then he can resolve this HTLC, because the HTLC says if Bob has the pre-image, the money goes to him. So he just shows Alice next time she gets online, hey, I paid your invoice for Carol, so I can resolve this HTLC now. And then we move into this state 5, where Bob gets the 1,500 sats, and we just resolve the HTLC off-chain, just like we do in Lightning. And this allows us to have routed payments where Alice pays Carol by just sending her some text, and Carol didn't have to do anything until she got online later to finish the payment. But even Alice didn't have to be online because the HTLC was already available for Bob to work with. So yeah, that's Hedgehog. It's some of the benefits are it's simpler than Lightning. Only 2 phases per state update rather than 4. Payments are off-chain just like Lightning, so they're cheap and fast. And unlike Lightning, the recipient can be offline. The recipient doesn't have to be running any software to do this. They can just they have to have a wallet, but that wallet doesn't have to be online when they receive money. So if you want more, you can find my GitHub, where I have an implementation of Hedgehog, except for the routing part. I haven't finished that yet. And that's it. That's the presentation. If you want, I can do a demo so you can see how it works, or I can take questions. Not sure what you guys want at this stage.
Yeah, let's absolutely. If anyone has questions, it looks like someone's already raised their hand. Go ahead, whoever's raised. I don't see who that was.
Hi, this is Hunter.
Hi, Hunter.
Hey, really cool work, by the way. I'm glad you're looking into like asynchronous payments type stuff. I'm kind of familiar with Matthew Corolla's work through LDK, and I know that they're upgrading LDK to work on PTLCs.
Mm-hmm.
Am I wrong? But I thought PTLCs were necessary for asynchronous payments.
No, they're not necessary. You can do them without PTLCs. It's similar to my ZapBlocker project, which blew up the Lightning Network for a couple of days while people got channels force closed. You can do asynchronous payments with HODL invoices, and Matt Corolla's original spec for this just suggested that you basically tell the other person's Lightning service provider that you have a pending payment for them. And when they get online, your Lightning service provider and their Lightning service provider complete the payment between each other. And I modified his by making it so that the recipient doesn't have to have a Lightning service provider. But yeah, they do work without PTLCs.
Okay, that's good to know, and that's really cool that you got it working without a second LSP. The other question I have is, you mentioned that this gets rid of 2 of the ordinary Lightning steps. Which 2 of those steps does this bypass?
Yeah. These 2. The step where you're waiting for Bob to ACK and revoke, and then the step where he sends you back an ACK and revoke message. Those 2 are eliminated because instead of the recipient revoking, the sender revokes.
Okay, that's pretty cool. And then also, does this differ or benefit at all from APO style LN Hance? or what is it? LN symmetry.
Yeah, it's not the same as LN symmetry because in the case of a force closure, you still have the property where the two parties have different transactions to do a force closure, and since they're not symmetric, they have different transactions to do it. It's not LN symmetry. Also, there's this property. It still has a penalty mechanism where if Alice tries to broadcast old state, she's revealed a secret that allows Bob to sweep her funds if she does not if she broadcasts that old state. That's in Lightning. That's called LN penalty model, and the APO upgrade is supposed to get rid of that in favor of just not penalizing someone for broadcasting old state. But this still has that, so it's unlike L2. But it is similar to L2 in that L2 also enables offline receiving, and this has that property. So it feels like you're using L2 when you're using Hedgehog.
Very cool, very cool. Oh, one other thing. Can existing Lightning channels be upgraded using Hedgehog?
In theory they could. One of the really brilliant things I think that the Lightning developers did is they made this upgradability. They built upgradability into Lightning using something called what's it called? It's okay to be odd. Where if you create a Lightning invoice, you're supposed to reference the feature set that your node supports, and they're numbered. Every feature that your node supports has a little number associated with it. And if there's an odd number, then the recipient or the other node who's trying to pay that invoice can ignore them. He can just say, all right, if I ignore these odd numbered features, nothing's going to error. We'll just fall back on using the old protocol. But if both of them know what the odd numbered feature means, like let's say it's the feature number 41 means Hedgehog, then both nodes could say, I know that I can do this using a Hedgehog, payment channel instead of a regular Lightning payment channel, and then they could, upgrade to using that. So yes, you could, because of the brilliance of the Lightning people, yes, you could update Lightning to support this.
That's very cool. So maybe one day you might want to work with like Core Lightning and LND and all them to like maybe update, like have this new way of doing things.
Yeah,
maybe simplify the code a little bit.
I did this presentation at Bitcoin Asia, and Elizabeth Stark was there, and she brought an engineer from Lightning Labs who I'd never heard of, but his name is Wei Wei or Wei or something like that. He's a Asian gentleman. And he liked it. He said he wants to make this Bolt 13. He was like, we should add this as a new spec for Lightning and just call it Bolt 13. So
that's great.
We'll see what happens.
Cool. Nice. Yeah, nice. I don't know if you want to be Bolt 13, but it sounds a little unlucky. But hopefully,
that's a lucky number. I think, Guy, you have a question.
No,
Go ahead.
Embrace it. Yeah. So what's up, Super?
Hi, Guy.
So I had a couple questions that basically we talked about last time, and I didn't have good answers for, and I wanted to, because I hadn't had my head wrapped properly around this, and in fact
I lost you, Guy.
Yeah.
Well,
like
it must have been a really tough question. The bandwidth, the internet couldn't even handle it.
Still can't hear you, Guy.
It says he's on.
they're still building.
There we go.
Guy, we lost you. We didn't hear your question. Could you restart?
Somehow from the information that Alex.
I start from the beginning of your question. You dropped off.
Oh, I did. Oh shit, my bad.
Yeah.
So I mistakenly thought that it was actually symmetrical because when Alice was pushing the payment to Bob, and because Alice was the one revoking, that Alice and Bob would actually have the same information to revoke the payment.
Well, they have the same TX1, which is similar to L2, but they have different TX0s. So if Alice broadcasts her TX0, then Bob can upgrade it to the latest TX1, which is similar to L2.
I see.
I guess, yeah, because in L2 it's supposed to be that you're always supposed to broadcast the latest state.
Yeah.
But if you don't, there's no penalty. And in Hedgehog, it's not quite like that. Whichever one is the most recent sender can broadcast the prior state, but then recipient can upgrade it to the latest state without a penalty.
So the latest state is the same until it's updated, and then both of them have their separate versions. But the previous state is still asymmetrical in the sense that like one of them is being punished based on what's being replaced.
Any states prior to the latest one get punished.
Gotcha. Okay. So then another question about, and you might not even have all the pieces worked out for this, but when you were explaining how the pre-image worked, I thought that the information being exchanged in Hedgehog was different than a normal HTLC. But would you be able to actually send a payment through normal Lightning routing channels with like Hedgehog at the beginning and at the end of the route? And basically people in the middle wouldn't even realize that there was a difference?
I've thought of a way since I talked to you to do that. I have to implement it to see if it works. One of the difficulties is that in Hedgehog the timeout on TX1 is always 2016 blocks.
Yeah.
And in Lightning, that's the maximum you can have in a payment route. Like ordinarily, Lightning HTLCs have a 40 block time lock, but it's actually 40 times n, where n is the number of hops in the route, and the maximum number of blocks it can be is 2016. So if you tried to route a payment through a Hedgehog channel naively by just attaching an HTLC to it the same as you would with a Lightning channel, you'd only be able to have one hop, because every Lightning node would think this is the maximum. Like whoever's doing this Hedgehog or whoever's in this channel tells me 2016. That's the maximum that a Lightning payment can do. And since they all try to add on 40, they would all say no, you can't do that. So it's really difficult to do it in the naive state. But I did think of a way to bridge them that I have to implement and see if it works.
So because a normal Lightning routed payment has to cascade the time locks, whereas Hedgehog doesn't, that there's that incongruency.
Yes, and there's also the fact that Lightning uses absolute time locks in payments, whereas Hedgehog uses relative ones. And so that's another thing. Like, if you tried to attach a relative time lock to something, your Lightning counterparty would be like, this is weird. This isn't what I'm expecting. So, yeah, you could do, like, if you were doing Lightning, and then...
I think I dropped out and missed your answer, but and if there's like a 6-second version, but otherwise I can go back and listen.
I just said it's also difficult that Lightning uses absolute time locks and Hedgehog uses relative time locks. That also would throw a wrinkle in it.
Yeah. I mean that's basically what I mean by that is that because of the absolute, like it has to enforce it that way. Okay.
But my another thing you can do if my bridging I thought of a way that I think will work to bridge them. If it doesn't work, the other thing you can do is you can build a wallet that has support for both Hedgehog and Lightning protocol, and then it can just switch between them depending on who it's dealing with.
If you're talking, I see a red zone, so maybe your connection's not so good. Super Testnet, this is Mark, the person who originally introduced you.
Update.
All right, go ahead. We lost you there for a minute.
Me?
Yep.
Okay. I was saying, yeah, that makes sense, and that was kind of my thinking, is that you would just need kind of both updating methods at the same time, and you would use normal Lightning whenever you found a route that there was a normal Lightning route, or there was a normal Lightning node in the route, and you couldn't use Hedgehog. It's like, okay, well, just use the other version. And with your channel party that is Hedgehog, you could still just update it and hold basically the Hedgehog update after the payment was complete. But for the route, you would have to use standard Lightning. Am I understanding that correctly?
That sounds like it would work. I'm not sure that you have to do that, because I thought of a way to bridge them, and I think it'll work, but we'll see. If not, yeah, then I would do it the way you described.
Sweet. Okay. And then the last thing that I had a question about is there any, like, let's say just using one hop as an example, you've got Alice and then an intermediary and then Bob, and they're going through like for an LSP model, right? Let's say Alice and Bob are offline, but like neither one of them can talk to the intermediary, but they can talk to each other. Is there any value or use? Is there anything that either one of them can do to essentially suppose a completed payment when they both get back online, where they can share the information? Where as soon as they can both talk to the LSP, it's completed, but they don't need to be online. They can make a trade offline, and then 3 hours later both come back online, and they both basically have the information to complete the payment to consider it settled.
Yeah, so in the model that I'm planning to use, Alice creates an HTLC with the that she puts in a state update for Carol, the intermediary. But Carol does not have to be online for that. Alice can just send it to her in an email and be like, "There's an HTLC inside your channel now." And then she sends the pre-image for that HTLC and the private key to that HTLC. There's 2 private keys in each HTLC, but she sends one of them to Bob. And then once Bob has them, he then knows, all right, I know that the intermediary has a pending payment for me, even if the intermediary is offline right now. So if he trusts that intermediary, then he can consider it like settled. But if he doesn't trust the intermediary, then he can't. And I would recommend not doing that.
Sure.
As him, I would wait till the intermediary gets online, then settle the payment, then give the product to Alice.
Gotcha. Is there something that I guess they would need different keys, so that might not work?
But the nice thing is, because Alice is only communicating because Alice just sent an email effectively to Carol, Alice could go offline, and then Bob can just talk with the intermediary when the intermediary gets online, and Alice doesn't have to be online that time.
Yeah. Now here's my question: is that can Bob verify? Let's say we're expecting Alice to send Carol an email, but we don't really know if Alice did that. Is this some information? Is this an information that's sensitive so that Bob can't have it, or is it something that Alice can send to Bob that says, okay, if you don't trust that I sent an email, well, you can send this information to Carol?
Yeah, Alice can do that. She can send him all the information. If she sends him information that builds on an old state, then when he sends that to Carol, Carol will force close on Alice. So Alice has an incentive to send him accurate information.
Sweet. So basically, Alice could forward all the information, obviously could forward it to Carol, but if Carol's not online and Bob doesn't trust that Alice is sending it to Carol, Alice can send it to Bob, and then Bob can send it to Carol whenever Bob gets back online.
Whenever Carol gets back online. Yeah.
I mean, excuse me, when Carol. Hell yeah.
Yeah, you could do that.
Oh, wow, that's clever. Okay.
But that's still no guarantee. If Bob trusts that Carol will, honor this payment, then that's fine. But maybe
it means that Bob can trust Carol instead of having to trust Alice if there is a.
Well, kind of, unless what if he's selling a giraffe to Alice, and Alice thinks it's worth a force closure to get a giraffe for free. She might send him bad data, and then he's like, well, okay, Carol, you have to force close on Alice because this is bad data, and Carol does, but Alice still has the giraffe, so.
Gotcha. Okay. Yeah, I mean, obviously there's still elements of trust, but it's just interesting that Bob can unilaterally try to redeem it without Alice with that information.
Yeah.
Now I do have another question: is are you still using that laptop that has a broken keyboard?
Yes.
We need to fix that.
That's unrelated to the current call. You can message me afterwards.
I had to ask because I think you were doing screen share. All right. Well, I have to bow out. I just wanted to kind of see the introduction here and ask a couple of questions for things that I was not able to answer last time, and I was afraid I'd give wrong information.
Excellent. Thanks for joining us.
Yeah, man.
Yeah.
Good talk, guys.
Do you-
Super. I'll see you later. Just hit me up on Telegram or
Yep.
whatever.
Does anybody want to see the demo, or are we good?
I'd like to see it real quick.
Sure.
I think I got a couple.
Yeah, please.
Okay, I'm going to share my screen again, so this might not go well, but we'll see. Okay, so I got,
We can see it.
yeah, I got one over there, and then I've got this person over here. Let me refresh both pages to clear everything out. Okay, so another cool thing about this is that because payments are non-interactive, you can also open a channel to someone non-interactively. And the reason that's cool is that I just implemented this today, or over the past couple of days. I implemented non-interactive channel opens. But the reason it's cool, I will show after I show it. So let's suppose that Alice is over here on the right, and Bob is over here on the left. Bob is some kind of service provider, like maybe he's Kraken, and Alice is just a user. So Bob just needs a public key and a payment hash from Alice, which I'm getting from down here, pub key hash pair. I'm just putting them in my console. And he's going to click Open Channel, and he is going to paste those in. It says enter Alice's pub key and revocation hash. And he's going to hit Enter. Now, it uses her pub key plus Bob's, because he has a pub key too, to create this multisig address right here. And it wants us to fund it. So I'm going to do that. Let me just open up my regtest node here, and so I can fund it. And I will do send to address. I'm going to send 10,000 sats to it. Oh, but I got to load my wallet first. Okay, so I put 10,000 sats in it, and it wants the transaction ID and something called a VOUT, which happens to be number 1 in this case, and an amount. So normally this would be done through an API, but in the demo I'm just copy-pasting it from my node. So the VOUT happens to be 1, and the amount happens to be 10,000. That's how much money he put into this channel. Now, you'll notice Alice didn't do anything. She wasn't even online for this. Like, she just, whenever she signed up for Kraken, she gave her public key and a payment hash to Kraken, maybe multiple of them, and now Kraken opened up a channel to her. And that's really cool, because let's say that you're right now with Lightning, it would be really awesome if whenever I do my monthly purchase from Kraken, like if let's suppose I have monthly withdrawals set up where I auto buy $1,000 of Bitcoin once a month and then send it to my cold storage. It would be really cool if that money, when they send it to my cold storage, was already available for use on Lightning. But we can't do that with today's Lightning Network because we don't have, because creating a channel requires getting pre-signed signatures and stuff, and you just can't, it requires interaction. But Hedgehog is non-interactive, so Kraken was able to open up a channel with Alice while Alice was offline, right into her, what do you call it, her cold card, and so that money is on her cold card and in a Lightning channel at the same time, which is really cool. So whenever she does get online, she gets an email from him that has this piece of text in it, and she
God, I did not think about this. Is that this means that you can actually do hardware wallet-based Lightning because you can receive payments without having to sign. And
Yep.
so whenever you wanted to send, you just break out your tap signer or your cold card and use it with your wallet.
I know, it's really cool. And
Oh, fuck me, that's awesome.
yeah, I know. Thank you. I'm glad you like it. So whenever she does get online, she sees an email from Kraken that says, "We sent you money into a new channel. Please, validate it." And she does, and it's like she gets a little message, "Yay, your channel is open." And she's got a little balance. So all the money's on her side, all 10,000 sats. If I do hedgehog.state, you can actually see the balance is in here. And it says Alice has all 10,000 sats on her side, and Bob has 0 sats on his side. But now she's going to send him some money. And Bob does not have to be online for this. She's just going to be like, maybe she's buying a giraffe from him. So she's going to send him 5,000 sats.
That is a cheap giraffe. I will take that.
It's a toy giraffe. But you'll notice, she just created this piece of text. Bob didn't have to do anything, right? So she just emails this to him, just like he emailed the channel to her. She emails this to him, and he just clicks, okay, she emailed me this piece of text. Boom. He has got money now. And if I do that same command I just ran, Alice knows it's 5,000 now, and Bob also knows it is now 5,000. And maybe she wants to buy something else, so she sends him another 1,000 sats. Boom. He does that. Now the balance is Alice has 4,000 sats, he has 6,000, and maybe 3 days later she buys some more Bitcoin, so they're going to send her part of her payment, in here. So they're like, let's send you 3,000 sats, and they can just keep doing this all day, right? Yeah. So that works, and then at any time either party can force close. So I will just do a force closure here. Like, let's say that Kraken stops existing, so she can't do a cooperative closure. So Alice can just click force close. It presents her with 2 signed transactions, and so she broadcasts this one, send raw transaction. There's the TX ID that went through, and she has to wait now. If she tries to broadcast the finalization, this one actually disperses the funds. It will not work right away, because there's a little error here that says non-BIP68 final. She has to give a period of time for Bob to check if this is the latest state, so that he can penalize her if she's doing the old state. But I've got it.
68 the time lock, I guess.
Yes, that is check relative time lock thing. But I'm going to generate a few blocks. I have it set to just a 5-block delay for now for testing purposes. But let me generate 5 blocks real quick. And now, if she tries to broadcast that transaction, it goes through. And if I decode that, there we go. She got 7,000 sats, and Bob got 2,000 sats. It would have been Bob getting 3,000 sats, like that's what the latest state said. But I've designed it so that the sender pays the fees, and there are 2 transactions where I hard-coded a fee of 500 sats each. So the sender, the person who most recently sent money, pays the fees for closing the channel, and thus he, instead of getting 3,000, he gets 3,000 minus 500 minus another 500 for the second transaction.
Wait, let me clarify this if you don't mind. So the fee is built in for the last person to have the update to pay the closure fee?
That's how I've designed it.
That's how you do it.
I actually think that.
I think it makes more sense than what.
Or incentives, because that means that if Alice has to force close on Bob, then obviously Bob needs to be paying that fee, because Alice is the one that's claiming that there's something wrong, that this is the last payment that needs to be going through. For that to be the last payment, I think the incentive needs to be that Bob is paying for that final payment.
I actually did it for a different reason. The Lightning Network, it's my understanding that the reason the Lightning Network designed it so that the person closing the channel pays the fees is because they want to disincentivize closing channels. They want you to stay in a channel where payments are cheap and fast. So they disincentivize closing a channel by making it so that whoever closes it pays the fees. But I don't really like that, because in Bitcoin, the sender pays the fees. Like that's how wallets have done it since the beginning of Bitcoin. And it's really useful to have that, because if you want to have the recipient pay the fees, you can emulate that by just sending them less money. And that's like how Bitcoin does. It's just like, do you want to have them? If you want to have them pay the fee, you can take it out of the money that you would be sending to them.
Yeah.
And so I like that better, because it gives you more. It just seems right to me. So
I think there's also not really much incentive to close the channel, because then you also have to open a channel again. Like it doesn't.
Yeah.
It's not like you're. I don't think that incentive is as strong as your. I think your reasoning is better, in my opinion.
Well, anyway, if anyone wanted to change it, there's just there's a line in here down where it's doing the balance updates, where you just change a plus into a minus, and then it flips it to the other person paying the fee right here when it's updating the balances. So yeah, it's really easy to change it just by switching these two. But yeah, that's how I did it. And yeah, so that's Hedgehog, and now you've seen a demo of it.
I also have a question here from Hunter, if you got it. Hunter?
Yeah, just one more, or maybe one or two more. So because the recipient is able to get a payment to their to an address that they might have registered on a node with their peers, doesn't that also kind of solve a little bit the inbound liquidity problem, especially if it was combined with an LSP?
I think it helps. Yeah, like, so the thing that I really want to use this for is on Stacker News. Because on Stacker News, they have a limit of 100,000 sats is the maximum they're willing to custody on your behalf. And, like, I use them for receiving zaps on Noster. So sometimes this thing happens where I'll be up near 95,000 sats on Stacker News, and someone will try to zap me for, 10,000 sats, and Stacker News will give them an error. It'll be like, hey, you can't do this because he's already reached his limit. And what I wish would happen instead is that they were running Hedgehog, and they would take that 95,000 sats, dump it into a new channel for me. Feel free to deduct the 5,000 sats or whatever it costs to open the new channel. But now I've got 90,000 sats in a channel that I can use on Lightning next time I come online. It's already, or on Hedgehog rather. It's already, connected. It's already working, and I freed up that capacity so they don't have to show an error. They can just They just give them a regular Lightning invoice and then I get zapped, and it starts filling up again. Up to my 100,000 limit. So stuff like that is kind of where I'd like to see this used. Because I think it really would improve the user experience of using Lightning applications.
Right. So, for example, you don't. Not only do you not need the inbound liquidity to receive a payment, but also, like in a semi-custodial model, it might even help where you're willing to custody up to a certain limit, and then it forces self-custody, and so that way it's kind of like batching large payments into channels.
Yeah, and if let's suppose that I had a Hedgehog channel already with Stacker News, and it wasn't, I had some inbound capacity on it. They could like split the swap. They could put whatever, if I had 5,000 sats of inbound capacity and someone's trying to zap me for 10,000, they could put 5,000 into my Hedgehog channel, filling it up without me needing to do anything. I can be offline, and then they can just custody the remaining 5,000 sats, and and just start increasing that up until my limit again. So there's a lot of cool things you can do with this.
So you can basically use it like a cache, like a buffer.
Yep.
Just like, here's the amount of buffer that I'm willing to accept as a customer, and then here's the limit that the custodian wants to accept or allow as a buffer, and then everything past that can actually use funds out of the buffer to open new channels.
Yep, you can do that with it. It really plays well with the way that a lot of services are run today.
I have one quick question about, and I have to bow out. Sorry. But the splicing. Can you unilaterally splice as well? Can you update the state of the channel?
Oh, I don't know. I'd have to think about it. I don't know.
I would assume that you would need to get the signature of the other person in order to change the UTXO specifically.
Yeah, but you could.
Time lock mechanism.
I'm trying to think through it. So very often in Hedgehog, I get away with this thing where it's like, I need the other party to do something, but I don't need them to do it immediately. So I just send them some data that I've signed, and I wait for them to co-sign it whenever they get online. So I wonder if you could do that with splicing. I don't know. But I have to think about it.
Gotcha. Well, we'll talk, dude. Thank you guys. Sorry, Hunter, for interjecting
Yes.
this.
Hunter, do you have any other question?
Later, guys.
Well, that was actually going to be my question about channel splicing, because this has a number of open channel components, where you it seems like you're going to accumulate channels pretty quickly, and ideally you're just updating an existing channel to get bigger, right?
Yeah, that would be great. I have to think about how to do that. I know that it took a long time to implement splicing for Lightning. I wonder if it'll be similar to implement splicing for Hedgehog. A similar amount of work.
Okay, good to know.
Hey, one of the things that I'm looking for is, I love to make these little proofs of... it looks like Guy just left. Can everyone still hear me? I didn't get kicked off too.
Yeah, delete. Yep, we can hear
Okay.
you.
So I make these proofs of concept all the time, where I show that something's possible that was previously not realized it was possible on Bitcoin. But I'm not really a good coder, and I would love somebody to take this idea and turn it into a real wallet or a real library that things like Stacker News can can implement into their services. Do you guys know? Would you guys be? I don't know. Do you guys know anyone?
You're looking for talent.
Yeah, because I don't have the talent. I just have the ideas.
Yeah. I'll throw that to the rest of the group, and we can also certainly post that in the chat as well. We're more about the implementation for the merchants and the shopkeepers. But anyone have any thoughts for Super Testnet on that? Any leads for talent who could turn his ideas into actual wallet?
Oh gosh. Well, like, I don't really consider myself a Lightning developer.
Mhm.
I mean, I've been working on Layer 1 for a long time now with RGB and stuff.
Well,
But
you don't have to commit, but DM me afterwards if you're like, you know what, I want to do this.
yeah. This
Or
is pretty
Hunter, if
cool.
you run into somebody you think might be well suited to help them out.
Well, one thing I was thinking was maybe an integration of Hedgehog into LDK would actually be pretty good because
Mhm.
then, like, you'd at least have one implementation, and LDK's in Rust, so I know how to work in it, and then like that might be, and also they're experimenting with asynchronous payments, and so that might make sense to integrate into the roadmap at some point.
Okay. Thank you.
Yeah. No, thank you. We really appreciate you taking the time today. One other question for somebody that wasn't able to make it. It's not really on your presentation per se. He might have been kind of alluding to your embassy coin join, but he asked if you're concerned about publishing privacy code. He put it in quotes. With the government going after, you if Russian oligarchs use it. So I don't know if that question makes sense to you. That was
Yeah.
his question.
I'm not worried about the government going after people who merely write code and put it on GitHub, which is all I did. But if they do, I will happily go to jail and then argue my case in court.
Yeah, I like your chances that it's speech. I think I'd be willing to defend you to the death.
Yep.
So, yeah. Well, hey, this was excellent. Any other final thoughts or from you, Super Testnet, or questions for you?
It's Michael here. Just wanted to say, blessing a lot, and I really wanted to say thank you what you're doing for the Bitcoin ecosystem, because it's really, I just wanted to thank you at this time, because it's really great what you're doing.
You're welcome.
That's everything what I wanted to say.
Thank you, Michael. I'm happy to make cool stuff and keep trying to push the industry forward, and I'm grateful to have friends like you along the way.
Yeah, thank you.
In fact, Super Testnet, how long do you think some of these tools that are out there are going to integrate into something that's so easy to use that people might even be using Lightning and not be aware of it?
How long do I think it will be until that situation?
There's a lot of tools out there that are really cool. You're obviously building a bunch of them. I'm sort of the resident boomer, so I don't know anything. Most of what you were talking about goes over my head. But what I'm wondering is, when will it become so easy to use that people will be using Lightning and these tools the way, whatever way they need to integrate, so that they're using it and don't even realize it?
I don't know. The hard thing is that in order to use Bitcoin, you have to have some. And I don't know how that part happens. Like, it's not exactly a technical problem. It's just that there's no legal way to give somebody Bitcoin without them signing up for it. So,
Right.
so they know if they sign up for it, then they know they're doing it. And if you do it illegally, then I guess I don't know I don't know how to comment on that
What
part.
I guess I'm wondering is maybe whether or not someone like a Visa or a MasterCard will eventually start using the Lightning rails to move value. So it's behind.
Mark,
they don't even see
they're
it.
already checking that. I know it for sure.
Yeah, they're already looking into that, Michael.
Yeah.
Okay.
Especially Visa is doing that.
Okay, interesting. All right, well, hey, thank you all for coming today, and again, Super Testnet, thanks for all you do. It's fantastic. Keep it up, and if other folks want to help you out in coding, we'll keep that in mind.
Thank you guys. Have a great rest of your day and
All right,
week.
you too.
Thank you very much.
Thank you very much.